Hello and welcome. We're going to do some more transformations today. So first off, let's look at what our three parent functions are. We have three kinds of graphs. We have a parabola, which is going to result from something squared, your variable squared. Okay, we have, I call it a half seagull, and that results from an square root. And last but not least, we have this V shape, and that's going to result from an absolute value. Alright, so depending on which one you're given is going to depend on your shape. You got to figure out what the parent function is, right? What shape are you looking at? Because that determines what point you're looking at. Keep in mind that when you're graphing these, your first point that you must graph are those three little orange points. Must be your vertex. Okay, if you don't use that as your first point, it won't graph it correctly. Alrighty, so first thing we're looking at, this is going to be absolute value, right? We see those two bars, so we know we have the V-shaped graph. Okay, why we care is that our V-shaped graph starts at 0, 0. Okay, and then for this one, it just follows essentially like a line. It goes over 1, up 1. So 1, 1's your next point. Next one is over 2, up 2. And you can also find these points the same way by just plugging them in, right? If you plug in x, you get out y. So plug in 0, absolute value 0, 0. You plug in 1, absolute value of 1, 1. Okay. Alrighty, so those are your points, and then it's just this right side, right? Your left side just reflects it. So instead of going to the right 1, up 1, it's left 1, up 1. Alrighty, so now we know what it looks like. Now we can perform the transformation. Let's identify what that is. So that transformation, when I'm looking at this, I'd say, okay, we have this negative 7/3. That is the transformation. And because that negative 7/3 is being multiplied implies some kind of what we call dilation. Alright, now it's either going to be vertical or horizontal. Now this one is a vertical dilation. Now how we know that's the case is you say, okay, your absolute value is right here, and the negative 7/3 is on the outside of that. It's not inside of the absolute values, right? It's not with the x, it's on the outside of what's going on. So, vertical. Okay, we have one last thing to worry about, and that's a negative. We call that a reflection. Specifically, it's going to be an x-axis reflection, because if it's affecting the y's, that's going to be moving up and down. In other words, it's going to cross that horizontal axis. So we call it an x-axis reflection. Alrighty, so for this one, you first plot your point, your 0, 0, because stretching something, right, if you're multiplying by negative 7/3, that's not going to change 0. Alright, now for vertical dilations of any kind, you do exactly what you see. You don't have to worry about doing the reciprocal as if it was in the inside. You just do as is. So instead of moving to the right 1 and up 1, you're still moving to the right 1, but now you are going down by 7/3. So this would actually be your point down here, because it's your y value, your positive 1, instead of going up 1, is being multiplied by that negative 7/3, which is negative 7/3. And from there, that's the same thing as negative 2.5. Okay, negative 2.5. So that's about, wait, where's that half coming from? 2 1/3. Negative 2 1/3. So down 2 and a little bit more at your third. We know that because we have that symmetry, you're going to have that same point on the other side. Okay? And then your next one is over 2 and down 2, or over 2, up 2, supposed to be in the original pattern. And then this one would be over 2, and then it would be down by 14/3. But you only need 2 points really to graph these, so you would just essentially continue down that particular road. Okay, so you just connect your dots, and here's your absolute value. Okay, and that is all there is to it when it comes to vertical dilations. You really just say, okay, it's multiplication, so that means you're multiplying your y values. There you go. Alright, thanks for watching.